Praveen, thank you for that introduction. Hello, everyone. My name is Steve Reynolds. I'm the Industry Principal for Chemicals here at AVEVA. Welcome to our discussion about Chemicals 4.0. Before we talk about 4.0, let's look at where we've been. The industrial revolutions are organized by the game-changing technologies that drive them. So Industry 1.0 was just steam power, mechanization, getting us off the handmade activities. Industry 2.0 saw electricity, mass production, assembly lines. Industry 3.0, the advent of digitalization and automation, saw a tremendous uptick in productivity. Industry 4.0 is further driven by technology, the Internet of Things, artificial intelligence, and really driving the connected worker. And if we look at kind of the core tenets of Chemicals 4.0, it's really about the interconnectivity of data, the information transparency, not only to our process, but within our organization, so that we have that real-time technical insight to drive decentralized and data-driven decision-making. So we want the people at the work front having the most information to make the best decisions possible. And where are we at today? The chemicals industry worldwide represents about 7% of the gross domestic products. Tangentially, not only direct industry employment, but the supporting industries and services driven by the chemicals, 120 million jobs worldwide. But in 2020, due to the COVID pandemic, we saw a 2.6% decline in overall output and production. We do expect to climb out of that here in 2021, but still problems abound. Not only do we continue to have the disruption due to the pandemic, but we're seeing supply chain and other struggles as we come to grips in the global community. And that brings about three key themes, really. The industry today is looking to reinforce those gaps in supply chain. We want to be more nimble and be more responsive to upset conditions. So look to our data community to begin sharing and applying that information across business boundaries. Our customers and our companies are focusing on their core businesses. So you're seeing a huge merger and acquisition market this year as they look to what's driving value, what is really important to the bottom line of our business. And we're adding to that, we're protecting that, but we're also realizing which businesses we no longer want in our portfolios, and we're finding outlets for those as well. And finally, the chemicals industry is responding to our ESG commitments, the environmental, social, and governance trends that are really driven globally, but are really finally starting to impact the chemicals industry. And you can see this from a variety of surveys that we have participated in. So industry and market pressures, 94% of our companies surveyed see supply chain disruptions. Over 50% of the CEOs look to sustainability as being a driving force in their preparations for the upcoming years. And many of us are seeing in-market shifts in demand. So as new products come on board, new materials, new processes, more sustainable processes are looking to be the demand going forward. And finally, throughout the pandemic and a growing trend throughout our industry is the advent of remote operations. Not only because of the pandemic, as we see our supporting teams work remotely from the plants, from our offices, we need to get data to those people, but also the control room is no longer the foundation of our day-to-day activity within operations. Mobile devices have enabled our teams to be that true connected worker and have the information at their fingertips as they walk the plant and conduct their work throughout the day. So where do chemical companies find value? If you've talked to me before with the PI system, you know we have the same priorities that you do. Our health, safety, environment, operational control, asset health, building operational intelligence. How do we do that? By improving your situational awareness, enabling hazard recognition, firming up your compliance tracking, becoming that system of record for your environmental and process data. The PI system, our operational control, asset health, providing process awareness, condition monitoring for your equipment, being able to optimize our yields, our energies, being out ahead of event detection and being ahead of the problems so that we run more reliable and more profitable as we go. And all we're building towards this operational intelligence. KPIs, building the dashboards so that we can manage by exception, integrate to higher analytics so that we can do more with the data that we have in real time, adding some self-service components so that people can get in and interact with the data, all the while driving that connected worker with mobile and remote access. And finally, being able to retain that knowledge within the system itself rather than in our spreadsheets or on our local devices or in our brains as we move from place to place. We can retain that knowledge within the plants and companies that can benefit from it the most. Some quick examples along those lines. So this is an example from Covestro. They've been a PI customer for many years, but it's foundational to their energy management program. If you look at the base of this structure here, the PI system forms the baseline monitor and control of energy management, identifying the opportunities, identifying the events and anomalies where they're running not to target, pushing those opportunities up to an aggregated energy management system, which allows them to identify trends and priorities, which pushes into their project management, which they can then prioritize and execute. And as those projects are implemented, we circle back to the PI system and update the data and the control limits so that we can sustain the gains. An example from Arkema for operational consistency. They recognize with many different reactors, many different product recipes, and many different control operators, there's going to be variability in how we run those processes and how we deliver that product. By using the PI system, we were able to monitor and monitor and assess against configured limits so that we know when we're getting off target, and we can look and coach those processes and those operations teams to get back on track and deliver better product with less variability in more efficient ways. Similarly, in maintenance, this example comes to us from Dr. Reddy's. This is one of my favorites because they start in the exact right place where I would start as an engineer. They looked at the critical equipment they have in their facility, conducted the FMEA, the failure mode and effects analysis for the fluid bed dryer, the coating machines, the compression machines, identified those critical conditions that indicated potential faults. They configured the PI system to monitor for those faults and alert them visually and through notifications so that the right people knew instantly when work was going to be possible. And this enabled them to enhance their condition monitoring program and get ahead of any reliability events that might impact those assets. And summing it up, from Petro Rabik is an example of a petrochemical complex where they're combining those events from operations, environmental, safety, and performance to look at operational reports, operational dashboards, asset health monitoring, production accounting, and also adding in that environmental component of flare monitoring. they do this by producing the complex or the site's asset framework, organizing the data in the way they need to see it for consumption, producing the daily reports, the dashboards for visualization and consumption by the necessary personnel. You don't have to just be a singular plant or a complex like this. We have numerous examples from our customers looking globally or regionally to develop those remote operation centers, combining key elements of maintenance reliability, process optimization, energy optimization into a regional effort as well as a local effort. So how do we do that? We talked at the front of what Chemicals 4.0 looks like, and we're really enabling that connected worker. And across our suite of technology, in addition to the PI system, AVEVA brings a portfolio of tools that really enables that connected worker and helps our transformation into Industry 4.0. And it centers around the digital twin. Within PI system, we'll talk about asset framework as our operational twin, and we'll begin adding the data that we need to make more sense and add more value to that real-time data. But the digital twin, at its essence, is just a digital representation of the data that we need to run our business and our enterprise. And it can come from a variety of sources. And it can really be driven by the needs of the plant or by the needs of the enterprise. So from an operations standpoint, from an engineering standpoint, from an asset information standpoint, finding the data that's necessary to make decisions at the best level possible. And continuing to leverage the power of the PI system. We want to build those contextual elements. Every plant has a reactor, a pump, a heat exchanger, compressors, other pieces of equipment, and other assets. How do we define those digitally? How do we organize it so that we can relate to the information and the information can relate to itself in ways that maybe we haven't thought of before? We can add those KPIs, those analytics to deliver that situational awareness, not only at our unit and local levels, but across our enterprise as well. Today, our sessions include Albemarle, Eastman, Air Liquide, and Covestro. I think they all hinge on great initiatives within the PI system and within our AVEVA suite of tools. Albemarle is going to talk to you about the use of PI event frames to drive their analytics package. It's a very innovative approach to combining batch data into a singular event frame and how they use that to drive analytics. Some of the visualizations are really key. Eastman has really driven analytics and event frames towards operator alarm management, being able to alert operations teams to the right alarms at the right time and how they track and visualize it is very great examples in that presentation. Air Liquide continues on their journey and provides us an update for the remote operation centers and how they use that for energy and yield optimization. And to round it out, Covestro is going to provide us an update on their journey with process simulation and connecting that with real-time data. And they have presented before on this opportunity, and they're going to elaborate on their use of AVEVA's process simulation and PI asset framework and how they think those two are going to be working together in the future. And if you haven't had a chance, please review AVEVA PI World 2021. In addition to these presentations and these talks, we had a variety of other presenters: Albemarle, Eastman, LyondellBasell, Covestro, Ecolab, Bayer Crop Science, and Air Liquide, all offering up their opportunities to help you in your continuing endeavors. And in closing, I'll leave you with this. Start simple, but simply start. The PI system, the AVEVA portfolio of tools, is incredibly comprehensive. You don't necessarily have to skip to the end. Understand your data, build that contextual awareness, identify the needs for how you define your digital twin, see how the data relates to each other. Begin by identifying those calculations that are necessary to do your business today. The anomaly detection, the event detection, how you define those will really drive the analytics and the possibilities down the road as you grow in maturity with the technology. And these will enable the artificial intelligence, the machine learning platforms, and all this is digital, which enables the continuous improvement to evolve as you go and identify those key sources so that you don't have to do the whole systems all at once. You can identify those initiatives that mean the most to you and your facilities. With that, I thank you. Again, my name is Stephen Reynolds. I'm the Industry Principal for Chemicals here at AVEVA. If I can help, please let me know. Thank you.